Hello guys and welcome back to this video. In the last tutorial what we did was we did the initial FMC setup and we completed it until the point where we get the load information document from the dispatcher, and that is exactly what has happened here right now. So if we imagine we've just received our load information document, so we can now prepare a performance tool, that is exactly what we're going to do. So going to our performance tool here, we can see we have Echo Kilo Bravo India, runway 27, and the intersection is full. We can actually do intersection mic just to see the performance figures. We have conditions 6 dry and the wind 160 at 9er, gives us our tailwind of 2 knots and a crosswind of 9, so that is perfectly fine. Outside air temperature is 13 degrees, QNH 1021. Landing dispatch, we're going to have a look here. We have Lime loaded up, runway 28, 3.00 minimum gradient on the MACG, 6 dry, wind 350 at 3 knots, outside air temperature 13 degrees, QNH 1023. Flap 40, air condition auto, anti-ice off, speed brakes auto, and no reverse credit. So if we just do a calculation with that, we can see that our landing weight is the limiting one with a maximum structural landing weight of 65317. So in Bergamo we should be good to go. If we go to our weight and balance tab here, we can see on the setup here that we have the placard weight is set to being 66,990 kilograms. We have a Boeing 737-8 winglets with special short field performance. Flight crew 2, cabin crew 4, we have catering on board and the duty free is loaded as well. On the passenger side, we've loaded up 170 adult passengers with 25 in the front, 118 in the middle, and 27 in the aft. Cargo side, we have 13 kilograms in the forward hold, and we have 250 kilograms in the forward hold too. The adjustments, we don't need to make any adjustments today. This is where if the air stairs were removed by maintenance, or for example if we have more catering or more duty free than what is in the standard calculation, we would add this right here. Fuel side, according to our flight plan, we can see that we have 4,595 kilograms of planned trip fuel. We have taxi out fuel of 113 kilograms, and a total load of 7,600 kilograms of fuel. And that gives us now, of course, this data would be cross-checked with the other pilot, so that we make sure we have the same things. But we do not do it in the way that, okay, I will just correct mine to what you have. No, we do it independently to make sure we have the correct one. And if there is a discrepancy, we're gonna dig into it and make sure that we find out exactly why there's a discrepancy. And then from there we can figure out what the correct option would be to do. So in the FMC, I usually start up by having the performance page loaded up because that is the one that makes sense. So what we would do is we would cross-check this and say I have taxi weight 65295, takeoff weight 64182, landing weight 59587, and zero fuel weight 56695. That's 56.7. 56.7 versus estimated 57 tons. That's a difference of 300 kilograms. We have on the passenger side 170 passengers and we were expecting 174. So that's a difference of 300 kilograms, and now we've just made sure, okay, we have 4 passengers less and it's a difference of 300 kilograms. So that actually makes sense. So it's not like we just put in any data, we cross-check it and it needs to make sense. If I put in this 56.7, we can see that gives us a gross weight of 64.3. So if we go back here to our landing dispatch, we could see that our landing weight limit was 65,317. So in that regards, it means that basically if something happens after departure, we can go back and land. It's not like we need to burn off any fuel. Let's execute this one, and I just noticed something that might be set wrong. There we go, it should be default at 5% CG here. The reason why, I'll explain more in depth in another video, but basically the margins, the low speed buffer and the high speed clagger is based upon this one, and we want to make sure it has the worst case possible so that it gives us the warnings early. Anyway, so now we plugged in the zero fuel weight here. We're going to go back to the N1 limit page, and on our performance tool we go to the takeoff dispatch one. So as mentioned, we have Echo Kilo Bravo India, runway 27 intersection mic, condition 6 dry, wind is 160 degrees 9 knots, outside air temperature 13 degrees, and QNH 1021. The rest is set standard. If we press calculate here, we will be able to see that we have a calculated reduced 22k. So this is the correct way to read it. Some people say, okay, flap 5, runway, blah, 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 takeoff weight, MFRA, blah. No. We brief it from the FMC, from what the FMC wants and into the airplane. So what we see here is we calculate a reduced 22k takeoff. And as soon as I press this one, I want to cross-check my crosswind limit. So today the wind is variable, and we have a crosswind of 9, so today it would actually make sense to go with a full rating. When the crosswind is 11 knots or more, we have to go with a full rating. But in cases like today where the wind is variable and there is an increase and a sudden decrease in the wind component, well, it would make sense to be on the safe side and go with a full 22k takeoff. So I press the full one here. And now we can see with a full 22k, we're looking at an N1 of 91.3. So we see here 92.1. How could that be? Well, if we go up here, we start our APU. You will see as soon as we put on the APU bleed that we would, of course, have the correct number. So while we wait for the APU and the rest of this, we can go up and do our overhead scan here. So yaw number on, normal auto, check the fuel valve. Put the 4 pumps on. Fueling is completed. Window heat on. $370 today. Landing altitude. We go in here and we go lime. Now we go for the charts for Bergamo, and we can find the ILS Zulu plate. And on here we should somewhere find the runway elevation. So as you can see, runway elevation 27 feet. So we can go with 50. It makes perfect sense. APU is up and running. Let's put it on the bus so the ground power, the ground crew can disconnect the ground power. Trim air can go on. Pax auto, isolation valve open, and now we can put on the APU bleed air as well. So let's go back down here now and have a look. So what do we see now? 91.3. Okay. So that is because the APU bleed air was not on. Then it does not give the correct one because the system thinks it has more APU bleed air available than it actually has. Anyway, so 91.3, that checks. On the takeoff page, it's going to be a flap 5 departure. I'm calculating a trim of 20.7. 20.7 gives me an FMC trim of 5.76, and I see 6.25 in the OPT. The reason why we have a discrepancy here, guys, is because if I show you here, on the payload side, you can see it is quite different to what we actually have. So in order to fix this, there's 2 things we can do. This is of course not real world. This is to make sure that we have the simulator set up in the same way as we have with our performance. So we can see we have 170 passengers. We had in the forward cargo a total of 263, and in the aft cargo 0. 57.2, and that is actually 500 kilograms too much. Now this is where the simulator meets its limitations, I guess you can see. But let's see now what it calculates here if we go to 0.7. So what I need to do is I need to do the correct trim here. So as soon as I pressed in the correct CG here from the airplane, from what it calculates on all the data it has, you'll see that it has a trim value of 6.20, and if we go back to the takeoff, 6.25, that is within the limits. So let's go down here and set the trim. That is 6 units, 6.5, 6.2. And with that performance, we have dry speeds 136, 137, 143. A little bit of a discrepancy here, 136, that's the difference of 2 knots, so we want to go with the OPT, that is the master, the low V1 speed. The rotate speed is within 1 knot, we can accept that one. And the V2 speed, 145 versus 142, that's a difference of 2 knots, so I would go with the higher one as well, just to be safe. And now we just need the MFRA, which is 1388. So let's go set that up. 1388. So that is the performance, weight and balance and the complete FMC setup done, guys. Next thing we're going to talk about in the next video that's going to come is how we prepare the airplane to fly the SID, and then we're going to push back. Hope you enjoyed the video, guys. Hope you can take out a thing or two out of this tutorial right here. If you have any questions or any suggestions or any requests for videos, please just let me know and I'll try and do my best to accommodate your wishes. Wish you a nice day and bye bye, guys.